Good day to all. Here we go again to discuss to you about quadratic inequalities. Then our learning competencies here. The learner must be able to illustrate quadratic inequalities and to be able to solve quadratic inequalities. So we will focus first on quadratic inequalities. We will set aside first the problems involving quadratic inequalities. So what do you need to understand here? Okay, so you need to understand here about quadratic inequalities. So we have here during your previous years in school, you encountered the following relation or inequality symbol and their meanings. So we have here the symbols of relations. So we have the symbols of relation, this symbol, and we have the corresponding word translation. This one is being read as, or can be translated into word as, is less than. And this means is greater than or is more than. So it can be is greater or is more than. Then this symbol is greater than or equal to, is at least or minimum of. So you can say is at least, you can say minimum of, or you can say also is greater than or equal to. Then this symbol means is less than or equal to, is at most, or maximum of. Okay, so these are the English word translation for these symbols of relation. So we will have here an illustrative example. Write true if the statement is true and false if it is false. So 5 is less than 3. Is it true or false? The answer is false because 5 is greater than 3. Then 10 is greater than 17. Again, it is false because 10 should be less than 17. So therefore, the symbol here must be less than. Next, negative 15 is greater than or equal to 12. It is again false because negative 15 is less than or equal to, less than 12. Sorry. Again, negative 15 is less than 12. So that is false. Number 4, negative 7 is less than or equal to negative 6. Is it true or false? Negative 7 is less than 6, negative 6. So it is true. So do not mind the equal to because they are not equal to, but it is less than, so it's still true. 34 is greater than or equal to negative 50. Is it true or false? Yes, because 34 is greater than negative 50. Okay, that's it. So we have here another. A quadratic inequality is an inequality that contains a polynomial of degree 2. So it can be written in the following form. So this can be, again, in quadratic form, but you will use the symbol less than or equal to, greater than, less than or equal. This must be greater than or equal to, because there is already a less than or equal to here, so this must be greater than or equal to. So make a correction there. Please take note of the correction wherein A, B, and C are real numbers and A must not be equal to 0. Okay, so a must not be equal to 0. Why? Because if a is 0, this is not anymore a quadratic, quadratic in quadratic form. So that is already linear. Next, we have here an illustrative examples. Which of the following are quadratic inequalities? Number 1 is a quadratic equation because you have equal symbol there. Number 2 is quadratic because the highest exponent is 2, but it is a quadratic inequalities because the symbol there is an inequality symbol that is greater than. Next, we have, again, this is a quadratic, but it is an equation because of the equal symbol. Then, another number 4, that is again a quadratic, but it is a quadratic inequality. Okay, so this is one also of the example of quadratic inequalities because of the symbol less than. Another, we have number 5 is also a quadratic inequalities because of the symbol. Okay, so only number 1 and number 3 are not quadratic inequalities. So 2, 4, and 5 are examples of quadratic inequalities. Okay, so in solving quadratic inequalities, you have to follow the following steps. Okay, so we have here, how do you find the solution set of the given quadratic inequality? X squared plus 3x less than 4. Okay, so number 1, our given is this one. Since the given is not arranged in standard form, so you have to arrange it by applying the property or addition property of inequality. So you will add both sides by inequality, both sides of the inequality by -4 to make the right side of the inequality equal to 0. So from here, we need to make this 0. So for us to make this 0, we have to add this one by -4. If you will add here -4, you have to add also on the other side by -4. So this will become now 0. So this is now x squared plus 3x minus 4 less than 0. From here, after that, okay, that is already in standard form, equate first that one to 0. Okay, so after writing that in standard form, equate first that quadratic to 0. Okay, next. What will you do next is look for the factors of the given equation. So factors of -4, that will give you, if you're going to add the factors, will give you +3. So factors of -4 are 4 and -1 because 4 plus the -1 will give you 3. Okay, so that is the middle term. If you add these two factors of 4, then the answer is not 3. Therefore, the factors are not correct. So dapat yung sum of the factors must be equal to the coefficient of the middle term. Next. So we have now the factors 4 and -1. So we have here x plus 4 and x minus 1. So these are the factors now of this quadratic equation. So again, that is by factoring and then using the or applying the zero product property, that is, you are going to equate each factor to 0. So that is x plus 4 equals 0 and x minus 1 equal to 0. Then solving or simplifying, so therefore roots are -4 and +1. So these are the roots of the equality of the equation. So we're going to plot those corresponding to -4 and 1 on the number line. So ito yung -4 on the number line, then this is your +1. So we will make it like this for a while, okay? Hollowed like that. So do not shade first this one. So just like this. Then from here, you have to create an interval. So this is your first interval, second interval, and third interval. Okay. So from there, you have to create intervals. So from here, these are the numbers, okay? These are the numbers less than -4. So, itong mga numbers dito are less than -4. These numbers here are greater than -4 but less than 1. And this side here, okay, are numbers greater than 1. Okay, so greater than 1. But if you're going to make an interval, it should be like this. Any number, okay, any number from here, okay, any number from this side, which is greater than 4, I mean, again, any number x here, I mean less than -4, but greater than -infinity. Infinity means boundless until there, and so on. So that is -infinity, because this arrow means it is continuous. So that is infinity. But since it is on the left side of 0, this is -infinity. And on the other side of the 0, it should be +infinity. Okay. So we call that as infinity. Okay, there. Again, we will make an interval, okay, wherein x should be less than -4, but greater than -infinity. Okay, so from here, the interval is in between -4 and +1. So any values from here, okay, any values from here greater than -4. So greater, lahat ng numbers dito are greater than -4. Then, but less than +1. So that's why you have any number, okay, any number from here greater than -4 but less than 1. In this interval here, it should be greater than 1. So these are the number greater than 1 but less than infinity. So you have any number, so you can let that to be x, greater than 1. So what are the number greater than 1? 2, 3, 4, 5, 6, and so on. Less than +infinity. Okay, so this can be any number here because that is continuous. Okay, so you have to create 1. Okay, so we will choose, after that, after making an interval, we have to choose test points. Okay, so we have to choose test points. From here, x is your test points, one of the test points. Then we have another test points from here, another test points from here. Okay, so in the example, you have the following test points. So we have to, okay, test a number from each interval against the inequality to determine the solution. So our first interval is x greater than negative infinity but less than negative 4. So, ano yung number less than negative 4? It can be negative 5, negative 6, negative 7, negative 8, and so on. But we choose negative 5. Okay, using again the equation or the inequalities rather, the inequality from earlier, okay, going back from earlier, from here, okay, from here, okay, from here. Using this inequality, quadratic inequality, we will solve. Okay, so we let x to be 5 from, negative 5 rather, from this interval. But you can also use negative 6, negative 7, negative 8, and so on. But not negative 4. Okay, because it should be less than negative 4. So, substituting, we have negative 5 squared is 25. 3 times negative 5 is negative 15 minus 4. So, 25 minus 15 minus 4 is 6, less than 0. Is 6 less than 0? False. So, meaning our solution does not come from this interval. So this is already excluded. Next, we will choose again a test point from the interval greater than negative 4 but less than 1. What are the numbers in between? It can be negative 3, negative 2, negative 1, 0, until 0. So again, the numbers are negative 3, negative 2, negative 1, 0. So you can choose any from those to be your test points. That is in between the interval. So, but here they use x equals 0. Then your x is 0 squared is 0. 3 times 0 is 0 minus 4. So therefore you have here negative 4 less than 0. Is negative 4 less than 0? Yes. Therefore, this interval is true. So therefore, the solution comes from this interval. Okay, so any number from this interval, if you're going to substitute to this quadratic inequality, the answer must be true. Okay, next. How about from this interval? What are the values of x? The values of x are 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. It should be greater than 1. Okay, so since we choose 3, so we have 3 squared is 9. 3 times 3 is 9 minus 4. Your x is 3. So therefore, 9 plus 9 is 18 minus 4 is 14. Is 14 less than 0? It is false. So therefore, our solution doesn't come from this interval. Next, we still have the test points. Another one is the negative 4 and positive 1, which is the roots earlier. This one. This is included in your test points. We call this as the critical points in inequalities. Okay, so your critical points. So we will also test your critical points. So if your x is negative 4, okay, negative 4 squared is 16. 3 times negative 4 is negative 12 minus 4 less than 0. So therefore, we have 16 minus 16 less than 0. Therefore, 16 minus 16 is 0 less than 0. Is 0 less than 0? False. Because 0 is equals to 0. How about if x is equal to 1? So another critical point. Okay, so we have 1 squared. It should be squared. It should be squared here. So 1 squared is 1. 3 times 1 is 1 minus 4 less than 0. This is 1 plus 3 is 4 minus 4 is 0 less than 0. So therefore, again, this is false. So from here, therefore, The solution for x squared plus 3 minus 4 less than 0 are those values of x between the intervals -4 and +1. So the solutions are the values of x in between, greater than -4 but less than 1, exclusive of -4 and 1. These are not included in the solution. So therefore, we have here, if we're going to graph it, -4 is hollowed. This should not be shaded because this is not included in the solution. This is also not included in the solution because we solved that and that is false. So it should not be shaded. So the only solutions are in between them. Lahat ng numbers dito sa gitna are solutions to the quadratic inequalities. Because if you try any number here to substitute in the given quadratic inequality, the answer is always false. True rather. Sorry. The answer is always true. So therefore, these are only the solutions. So therefore, the solution set should be, okay, in symbol, we call this as the solution set. Set containing x such that x is greater than -4 but less than 1. So this is how you're going to write solution set. And this is how you're going to graph quadratic inequality in a number line. Okay, that's it. Again, going back. Again, the solution is, first, you're going to write it or change that in standard form. So, in standard form, okay, standard form, then equate that to 0, find the roots. Okay, again, write in standard form, equate to 0, find the, using factoring or whatever method that you could use, then find the roots. And these are called critical points. And from here, you will plot on a number line. So -4 and +1. Then create or make an interval. So there are 3 intervals. Then from these intervals, you have to choose test points. So test points from here, test points from here, test points from here, and the critical points also, okay, included as the test points. Since this is false, this is false, this is true here, this is false, this is false, so therefore these are not included in the solution. These are not included in the solution. So the only solution set to the given quadratic inequality is just in between -4 and 1. So the solution set is the set containing x such that x is greater than -4 but less than 1. So these are the solution set. So that's it. Then we will continue in the next meeting about problems involving quadratic inequality. Have a good day ahead. Thanks for watching. Please subscribe my YouTube channel for more updates. Thank you.